So considering the work that we did yesterday in the lab, we're going to now take the techniques that we used into the real-world sampling. So we were going to move from the lab out into scenarios that you might encounter as a first responder and where you would likely want to use PSPME IMS. I will present some sampling considerations and as well as some recommendations for you when you are conducting this type of samples. The outline of this presentation is as follows. Yesterday, in my lecture yesterday, we covered contact sampling and non-contact sampling briefly, but in this lecture, we'll go more into depth of both types of sampling. And then we will apply each type of sampling to the screening of vehicles, and we will show you how, in what scenarios to use each one. And following that, we will go into the background and possible distractors that you might encounter when you're sampling a vehicle. And this applies to both canines and instrumental techniques that we will be using. So this is a photograph of Edmond Locard, and he was the crime lab director of the first ever crime laboratory in the world, and it was in France. And the idiom that we all know today from forensic science is every contact leaves a trace. But moreover, at every scene, you always leave a trace and you take one with you. So there are different types of transfer. You can have primary transfer and secondary. So the primary transfer would be you leaving your DNA on a victim. A secondary transfer, for example, would be an assailant fiber from his carpet in his apartment being left on a victim who has never been to that person's apartment. And that's an example of a secondary transfer. And some different types of trace evidence include hair, DNA, shattered glass. And the key when we're using both a sampling and detection technique is how sensitive both are and how efficient we can be at collecting these trace samples and preserving them. So where do these traces come from? For our purposes for this workshop, we're describing explosives and drugs. And they come from the actual book or explosive drug itself. So it could either be by the concealment of the drug or explosive, from the person handling or packaging it, or the vapors that are being emitted from the packaged substance. Now, contact with contaminated hands can transfer this type of evidence to clothing, luggage, door handles, etc. Or for instance, when a bomb maker is closing a cardboard box, you might see evidence or trace particles of the explosive itself in areas where you would seal the box. You can also obtain explosive particles on fingerprints that can be transferred, for instance, to a person's license. Also with contacts with tools and workspaces, even someone that is not directly involved in packaging a drug or explosive might make contact with these workspaces, and this is evidence of them being associated with the perpetrator. And also, again, going back to the odor emanating from the concealment. So here we see the printer bomb that was recently in the news, and they actually packed 7 pounds of PETN into this printer bomb. Now, with instruments being configured to detect the volatile chemical signatures, such as N-butyl acetate that come out of, that are emitted from PETN, and having an efficient sampling methodology and device for collecting these volatile chemical compounds, you could detect the presence of PETN. So we have, again, contact sampling, and this involves the wiping of a surface and in the hopes of collecting particles. So here on the lower left we see myself wiping a white piece of butcher block paper with a GE swab. And with non-contact sampling, we can also collect vapors by trying to vacuum in and capture particles onto a filter material. Or we can actually try to collect vapors that are emitted from the explosive. And again, this depends on the chemical and physical properties of the threat agent itself. So there are explosives that have the energetic itself is volatile enough, and most of them are not. But they again have these additives or solvents or extraneous compounds that emit these vapors that can be collected. So when you're doing sampling, you also have to consider the surface. So if you're doing particle removal, you might have a harder time sampling, for instance, a piece of clothing that is made of cotton as compared to sampling a smooth linoleum surface or a tile. So these are all things that you have to have in mind when you're trying to select a way of collecting your sample from a suspected area. And here on the bottom right, we see myself within a LD3 container, and we're taking a blank, just like you did for the cans, to assess that the container that we're going to place our threat agent in is indeed blank and does not produce a signal by IMS. So for particle sampling, the most common way of collecting your sample is by surface wipe. And in general, the surface wipes shown at the top, these are commercially available, and you will be using at least 2 of them throughout this workshop. They actually need to be able to conform to surfaces. So not always will you be sampling a flat countertop. So they're malleable in that way. They're generally low cost because for each sample you should use a new collection device. And they're all directly introduced into the ion mobility spectrometer through thermal desorption. And you experienced that yesterday when you were actually introducing the wipes from the manufacturer and the PSPME devices. So again, the heat from the desorber evolves your compounds off and directs it into the ion mobility spectrometer. So here on the bottom, the picture you see, are different types of wipe materials that are available for us to sample surfaces for drugs or explosives. These include texture vinyl, cotton, muslin, Teflon, PTFE. And NIST recently did a study, and they showed that actually the composition of the wipe material itself is more important and contributes more to the amount of particles that you collect rather than the force that you apply itself. So that shows how important it is to select the correct type of wipe material for the sample that you're looking for. So where do we conduct particle sampling? We do this on surfaces that you expect to have come into contact with tools or hands that have been contaminated, such as luggage handles, a gear shift, a door handle of a car, or the trunk, the steering wheel, for instance. And you would swipe that surface, and then afterwards you would do the analytical technique for detection, whether it be direct introduction into ion mobility spectrometer or placing that wipe into a solvent for other types of instrumentation. You could also conduct sampling of particles in large containers, such as this LD3 container you see from FedEx, and larger containers such as for cargo and in shipping scenarios. And here, researchers have attempted to actually evacuate the air from these containers in the hopes of catching one or a few particles and then introducing it into the instruments. So how do we determine how efficient our wipe method is for collecting these samples? Well, NIST recently came up with a standard reference material. It's 2905. And what it does is two-pronged. First, it provides you with a known concentration of TNT and C4, which is mainly RDX and HMX. So to begin with, we know the mass of that explosive that is incorporated into these particles. And you'll be working with these later on today. Now, besides that, they're also fluorescently tagged. So with the help of a blue crime scene light and your orange glasses, as you see here, you will see the area that contains particles fluoresce. And you can visually see that you have collected your sample. So you can actually test different wipe materials in this method and determine which one works best for this standard reference material. Now, besides you seeing it visually, even though, for instance, you might see a faint fluorescence, you can still introduce that into the instrument and you will see a response for the TNT if that's the one you use, or the RDX from C4. So for non-contact sampling, again, we have particle collection and vapor collection. And with particle collection, the main vehicle of doing this is by the use of modified dust busters. We also have tubes that are adsorbent or membrane filters that can be used to actually capture the particles and hold them until you can introduce them into the instrument. Now, we also have vapor collectors, and these again can be used through adsorbent tubes, metal felts, SPME devices here, or the SPME that is shown here. And these all have increased pre-concentration power as you go up along this chart. We also have Sandia's pre-concentrator, which is a metal mesh, and that pulls in large volumes of air to capture your particles, and in some cases, vapors as well. Okay. So when you've decided to do a vapor sample, you want to say, what am I looking for? What is my sample? So does your sample contain constituents that are volatile enough to be collected? What are the options for collecting this sample? Do I have a long dwell time, meaning how long do I have that I can dedicate to just sampling, sample collection? For instance, if you're in a shipping scenario, you might have upwards of 1 or 2 weeks during transport to just leave your SPME device in there until you get to your next port. Or in an airport scenario, you just might have seconds in between passengers. So you have to fit the sampling methodology to the sampling scenario you're in. And then also in respect to SPME, that would help you determine whether you're going to do a static mode extraction or a dynamic mode extraction. So will the method that you finally select collect enough vapor for detection? Remember, this is important, and the dog trainer again alluded to this. There has to be enough vapor in the air for you to detect it. Now, we can aid this by having an efficient pre-concentrator. So you can have small amounts of vapor available, but if you have a very efficient pre-concentrator, then you can still detect it. And you also have to consider how far from the vapor source you are. And lastly, we have environmental conditions. Temperature affects the rate of volatilization of these compounds. Also, background contamination might affect your instrument response. You might have competitive ionization with other components, or you might have an interferent that masks your peak, detectable peak. And that's why we have operating condition optimization to minimize these factors. So a South African mine clearing company called Mechem came up with this remote explosive scent tracing technique. Now, what they do is they sample large areas of suspected to contain mines. So for instance, they'll send teams on foot with a suction sampler, shown there. And they'll actually suck large amounts of air in through and absorb them on these absorbent filters. Now, once they've collected this sample from an area, each of these absorbent tube samples are labeled with a designation to correlate back to the area you sampled. Now, they go to this clinical laboratory where they have trained canine teams, and they present these to the dogs. So one dog has a 90% detection rate. But when they have, their actual teams are composed of 3 dogs, and that is enough for you to certify whether a mine is not present in the area. So you can clear that and say that that zone is okay. So 3 dogs is what they use. Again, here you see a canine that is being presented with the odor that was collected from the suspected area. And again, they can go back, because it's labeled, to the place and say that there is no explosive present. And the reason they can do this from the vapors is because the mine or the unexploded ordnance emits these odors that we were talking about yesterday that provide a unique vapor signature. So if you can collect that and detect it, and in their case they're saying that it's not there, then they can clear that area and move on. So non-contact sampling can also be achieved by SPME. We have either the dynamic sampling mode or the static sampling mode, as you guys experienced yesterday. And again, as Dr. Almral said yesterday, we made the cover of drug testing analysis showing our methodology for using SPME IMS. So vehicle screening is something that you might encounter as a first responder. If you have a suspect vehicle, you might want to see if there's concealed drugs or explosives there. Or you might want to see whether the passenger or the driver has been handling contraband, and that might be useful to your investigation. So there are several methods that you can use, and the first is the most simplest, which is just visual inspection. You can also employ canine teams. You could do bulk detection such as X-rays, as we showed earlier yesterday, and we can do trace detection, sampling, and collection. Okay. So I'm going to show you now a video of Customs and Borders Protection System for large venues, and they use an X-ray system called VAXIS.
This will be used for pretty much all the vendors and cargo or supplies and some vehicles that will be entering into the or proximity of the Super Bowl area. And what we're going to do is X-ray or examine those vehicles, a non-intrusive examination. The operators of this vehicle, this system, are highly trained. What we're looking for is that unusual anomaly in something that we would normally not see. This machine is able to pick that up and identify. What we can do with that is take that information and then go into it further and identify what possibly could be wrong or what could be there that's not normally in that cargo or in that vehicle quarter panel or tire. And that's what we're able to do with this machine, is actually take a snapshot or an actual image and be able to visually look at it and evaluate it.
And now, as far as vehicle screening, doing trace collection and detection, here's a video from Smith's Detection using their Sabre 4000, which I think one of the students has to work with. And mainly the point of this video is to show you how to sample surfaces for particles efficiently.
The Sabre 4000 plays an essential role in a total security solution. The Sabre 4000 provides unparalleled mobility and versatility from gatehouse to building protection. It detects particles and vapors, identifying more than 40 different explosives, narcotics, chemical warfare agents, and toxic industrial chemicals within seconds. No computer or external system is required. At 7 pounds, including battery, it is the lightest portable trace detector available and the most effective. The Sabre 4000 has 2 operating modes, particle and vapor. Particle mode primarily detects explosives and narcotics. A sample is collected from high contact areas to find trace particulates. Once inserted for analysis, results are complete in 10 seconds. Traces at low nanogram levels can be detected.
So you noticed how he sampled the trunk of the vehicle, the door handles, and the luggage itself. Here's just some more vehicle screening examples.
Buying explosives, narcotics, CWAs, and TICs. Detailed analysis in 10 seconds and a throughput of 180 samples per hour.
Okay. Now there are possible distractors whether you're employing a biological detector such as a trained canine or an instrument. And these materials can produce extraneous odors that might affect your sample collection and detection. So these could be possibly perfumes or a car freshener within a vehicle, and they might cause interference with the drugs, the volatiles that you're extracting from the drugs or the explosives. So here we have pentolite explosive, and then we have cocaine and MDMA as examples. So in the Almerol group, Dr. Han Lai performed a study to determine if there were interferences with the detection of cocaine, MDMA, and marijuana using her optimized operating conditions on the ion mobility spectrometer. And for marijuana, she found no interference with the compounds that were sampled. So for instance, green tea leaves, black pepper, dried mushrooms. These are items that you might possibly ship the contraband with. Now, for piperidinol, she also didn't find any interference with the compounds. But unfortunately for cocaine, under the instrumental conditions that she optimized, we did see an interference with a peak originating from the green tea leaves, and it was masking the peak that was detected for cocaine. So in this case, it could present a problem. Now, there are ways to get around this. You can have a sample collection method that has a specific chemistry to only attract the volatiles that are coming from cocaine. In this case, it's methylbenzoate. And then that way it would eliminate other contributions from the volatiles that are coming from green tea leaves. Or you can do modifications to the IMS instrument in terms of the dopant or drift tube temperature to see if you can get around that interference. So Dr. Lai also performed a study to show that the solid phase microextraction IMS method she came up with was actually robust. So she did a blind study, meaning that someone else prepared cans for her. Now, some of these were blank, and some of these contained the MDMA. And she correctly identified that the first 3 cans, A through B, contained pyperenol, which is the odor signature for MDMA, while the rest did not. These were free. So at first she was a little wary, thinking that she thought it would have been distributed more evenly, but in fact it was that the first 3 cans contained the drug, the parent drug. Now we performed studies on MDMA tablets at the Miami-Dade Crime Laboratory using the planar solid phase microextraction device that we've been using in this workshop. And they were actually sampled and analyzed at their facility using a Itomizer 2 instrument with the PSPME device. So here we see that for even 1 tablet, we get a huge signal for PSPME device, upwards of 40 nanograms. But if you go higher, you'll see that the PSPME has so much ability to absorb your volatile chemical compounds that you're actually seeing huge signal for this dimer. So the dimer is 2 essentially molecules of your analyte of interest coming together, and that happens at very high concentrations in the ion mobility spectrometer. So really you see that with the SPME fiber, you have much less extraction efficiency, although you are able to see your analyte. And this just shows the pre-concentration power of planar solid phase microextraction. Another interesting study was that the analyst at Miami-Dade Crime Lab prepared different cans for us, and he didn't tell us what the contents were. So we had 6 cans, and we also had a 7th blank. And in all cases, both the SPME fiber and the PSPME fiber, which obviously has more surface area and ability to pre-concentrate, detected both monomer and dimer of the pyperenol compound that we were detecting. But the thing to note here is that the PSPME device was so sensitive that in case 1, which was the most difficult case, the case that contained the least amount of MDMA, you were able to detect about 15 nanograms of pyperenol, which in the SPME fiber, there was no response. So had you been using your SPME fiber to test for this compound, you would have falsely identified that as being clear and not having MDMA, when in fact it did. So again, this just shows the ability of PSPME to collect your analyte and pre-concentrate it. So now to our biological detectors, which again are the gold standard for detection of odors emanating from drugs and explosives. So Mythbusters actually made an episode trying to see if there were any potential distractors that can fool the trained canine. And they tried compounds such as coffee, peanut butter, bleach, etc. And in all cases, they were busted. So we'll actually see a portion of the video, which is very interesting to see how they tried to mask the odor or distract the canine later on. And we'll refer to that in a bit. Okay, and to conclude, the sample media for surface wipe sampling may be evaluated visually and instrumentally using this standard reference material that you'll be working with in your next exercise. When sampling for vapors, however, you have to note that there might be potential background interferences, as the example is for cocaine, where green tea posed an issue. But again, there are ways to get around this through instrument modification and modification of the chemistry of the PSPME device. So just to summarize, plain or SPME, you can either have a static sampling mode in the closed system or dynamic. You can have the system closed ahead of time or just sample an open system throughout. Now, static in a closed system, ideally you would do it in a situation where you have a long time available for you to sample. Again, such as the cases where you have a shipping container being delivered. And this is because it has the highest capacity for absorbing your odors because it has more time to interact with your compound. Now, with dynamic sampling, you have the advantage of being able to sample on the order of seconds, and this would be useful through high throughput applications such as vehicle screening. So furthermore, with vehicle sampling, you have the option of doing particle sampling, vapor sampling. In the case of PSPME, you would probably do a dynamic PSPME experiment near that suspicious item. Just like the canines do, they bring their nose right up to the area before they sit or perform their alert. And then there are cases such as vehicle sampling where PSPME IMS may be used to screen before any further tests or samples are taken to a laboratory. And the advantages, again, of PSPME are they're generally low cost, and this is due to the fact that they can be used up to 100 times as long as you clear it out, blank it out. It's generally easy to use, as I think you experienced yesterday in the laboratory. And we can easily adapt them to the existing IMS systems that you have at your facilities currently. And you have different options of how to collect your sample. So if you want to ever go back and see the cited references throughout this presentation, they're here. You can see more about the experiments that we performed. And if you have any questions, I'll be happy to take them. Adam?
Just a scenario of thought. Person complains that they have an odor in their house over a long period of time. Let's say we took a PSPME, hung it in the rafter of a basement, and just allowed it to be there over time. Looking for anything that might be of interest to that house. Maybe they're smelling something coming out of the sewer. Maybe they're smelling their neighbor's house flushing down methamphetamine chemicals or something down the drain. Would this work in that type of environment?
What you have to consider is we know that PSPME is actually very efficient at collecting odors. So you have to figure out which instrument you're going to use to couple it to. So if you're suspecting drugs and explosives and you have an IMS instrument that is configured to that, and even the agents that are being used for the manufacture of methamphetamine, for instance, if those are programmed, you can go ahead and take one sample to that instrument. But if you're talking about other type of contaminants that you would need a different instrument for instance, a GC or an HPLC, you could still perform PSPME sampling, have it collect the odors, because we know it's efficient at that, and then you would do some sort of extraction method. And it could be through a solvent. You can expose it to a solvent and maybe sonicate it, and then that would pull down the analytes that are trapped on there, and then you would place that solution that you've extracted into another type of instrument that has a capability of scanning for many types of threats. So it's something that involves maybe a mass spectrometer that you can identify by the fragmentation what compound that is. So, because for the PSPME, really what we're showcasing is that it can collect odors. Now you have to, in the appropriate situation, couple it to the right detector.
Right. So then the other piece of that is if I'm in a venue, large venue, and I want to screen people and packages quickly, I'm not necessarily going to want to spend 30 seconds vacuuming up a sample around a person and then run it. I mean, can it be cut down to a few seconds of vacuum sampling to expedite that? I mean, what's the minimum time that you have to collect with your vacuum sample for that swipe to be effective?
I think that for that type of scenario, at this moment, we haven't done those studies to see how low can we go to see if odor is emanating from someone that hasn't been in contact. I think that would be really pushing the limits. So,
probably depends on your source also, how much.
Yeah.
I'm sure there's all kinds of factors.
And Dr.
Windage.
That's exactly right, Tom. It really depends on the available odor. So we have done some experiments, but we haven't done exhaustive tests yet. That would be the next step for us. For example, we went to the University of Rhode Island and we took 10 milligrams of solid TATP and did a 5-second dynamic extraction and got a huge signal, overloaded the instrument with these beams. So that's just an example. But it really all depends on what is the source, as Tom said, how much available odor is there, what's the volatility. So it really depends. It's a lot of variables. So those are the things we're going to work on next.
Any other questions? Okay, thank you very much.